Hello everyone. In this video I'll discuss about high nuclearity carbonyl clusters, in short form or in short HNCC. Okay, so first of all definition or definition to no need, only for this one have to understand this one. Okay, see, high nuclearity carbonyl clusters have metal atoms greater than equal to 5. Okay, greater than equal to 5, each forming at least one metal bond, each forming at least one metal bond. The first HNCC was discovered to be, so this one is example. So this one what, the first high nuclearity carbonyl cluster was discovered to be RH6, this rhodium 6 carbonyl 16. So this one is example. Or what is the example of high nuclearity carbonyl cluster? This is first high nuclearity carbonyl cluster is RH whole 6 CO whole 16. Okay, now the structures of the HNCC can be determined by skeletal or framework electron counts with the help of Weights rule. Okay, this will very important for CSIR-NET, GATE and IIT JAM also. Okay, so first one, this step number 1 or first step, calculate total electron count. To calculate total electron count. Second number, add to total electron count the valence electrons for interstitial atoms. Means, for example, see hydrogen. So hydrogen, how many electron can share or can donate? Only 1. For carbon, how many? 4 for carbon, then 5 for nitrogen, 5 for phosphorus and so on. Okay, this is point number 2. Then point number 3, each metal atom utilizes 12 electrons. Each metal atom utilizes 12 electrons and each CO ligand utilizes 2 electrons. Metals, how many atoms utilizes? 12. And ligands, here ligands is CO. CO how many? 2 electrons, irrespective of its bonding terminal or bridge for non-skeletal bonding. Okay, non-skeletal bonding. Now point number 4, calculate polyhedral electron count. So this is formula, polyhedral electron count equal to total electron count minus 12 into n. The total electron count minus 12 into n. This is formula for polyhedral electron count. Okay, here n, what is the meaning of n? Where n is the number of metal atoms, n is the number of metals. Okay, so let me see another point. See here, point is, okay, wait a minute. 5 number, calculate then polyelectron or polyhedral electron count divided by 2. If polyhedral electron count divided by 2, that means n minus 1. Okay, this is n minus 1. So you can call or you can consider as a superclozo. If n minus 1 means polyhedral electron count divided by 2. So polyhedral electron count divided by 2 or skeletal electron pairs. If n minus 1, then superclozo. Polyhedral electron count divided by 2. If n equal to n, that means hyperclozo. If n, then hyperclozo. Understood? Now, if polyhedral electron count divided by 2 equal to n plus 1, then you have to consider closo. This is closo formula, n plus 1, then closo. Then if polyhedral electron count, suppose polyhedral electron count divided by 2, then you will get n plus 2. This one is called nido. If n plus 3, this one is you can call as arachno. Now polyhedral electron count divided by 2, okay, equal to n plus 4. This one is called hypo. Then n plus 5, this one is called calado. Okay, so these are formula. Okay, now see in this table, you can see, is it visible? I think yes, visible. Okay, see this is table structure type. Okay, structure type, then boron, and this is transition metal clusters. And TE, this is total electron count, skeletal electron pairs. Then again here total electron count, and polyhedral electron count divided by 2 means skeletal electron pairs. Okay, for structure type, for closo, then this is for boron. In case of boron, then 4n plus 2. Okay, if total electron count is 4n plus 2, then have to call closo structure. Or skeletal electron pairs n plus 1, then have to call this one is closo. Or for transition metal clusters, then total electron count, suppose 14n plus 2. This is formula, 14n plus 2 means closo. N plus 1, this is also closo. Okay. Now nido, for nido, so what is the formula for boron? 4n plus 4, 4n plus 4, and skeletal electron pairs n plus 2. Skeletal electron pairs is n plus 2. And for transition metal cluster, 14n plus 4, n plus 2. Okay, this one. For arachno, same, 4n plus 6. Okay, 6, 2 have to more. See, 4n plus 6, n plus 3, here 14n plus 6. Okay, this one. So here this is same, hypo like this process, 4n plus 8, n plus 4, 14n plus 8, then n plus 4. Then calado is formula for boron cluster, 4n plus 10 and n plus 5, and for transition metal cluster, 14n plus 10 and n plus 5. Okay, so these are formula. Now some examples will do. Okay, some examples. Okay, let me see this one. Yes, this one, this example. First example here, this is rhodium. Okay, now here n value is what? N equal to 6. Okay, now this cluster compound, this cluster compounds is closo cluster or nido cluster or arachno cluster or hypo cluster. So first of all, see this one is RH. RH is what? Transition metal. This one is transition metal. Okay, now I have to find out total electron count. Total electron count. See, 6. How many? RH 6. And what is the valence electron? Valence electron is 9. Okay, valence 9 plus 16 into 2 equal to, then 6 9 is the 54 plus 32, then you'll get 4 plus 2 6, then 86. Okay, 86. Now see 86 now, this is transition, so what formula have to use? Transition. Okay, this one total electron count. Now we see this one or this one. Okay, let me see. Okay, 14 into 6 plus 14 6 for that how much? Then this one is, suppose say 6 for the 24, then 2 carry, then 6 on the 6 7 8. Okay, 84. How many left? Then 2. That means this is what type of structure? This one is closo structure. Okay, closo structure. if 14n plus 2, 14n plus 2 like this, 14n plus 2 equal to what? Closure structure. Okay, closure structure. 14n plus 2, here n value is 6, then 6, 14 6 are 84, 84 plus 2, then 86. Okay, next, so this is osmium. Okay, now again total electron count 5, n value here, n value is 5, 5 into, now osmium, this valence electron is 8. Okay, plus carbon is 4 and 2 into 15, so 40 plus 4, and here is 30, then 30 is and 74. Okay, 74. So let me see, now this is transition metal. Okay, so transition metal cluster, so 14 into 5, 14 5, and 14 5 is a 0, then 70, 70 plus 4, that means 4. This is what type of formula? This one, 14n plus 4, 14n plus 4. Okay, 14n plus 4, this is nido structure. Okay, so structure type is nido. Okay, nido. Next, similarly here n value is how much? N value is 5, then 5 into, now total valence electron, to total valence electron is what? 10. So what is the valence electron of nickel? 10, group number 10, plus 12 into 2 plus 2, this one have to add. Okay, so you'll get 50 plus 24 plus 2, then here 6, 76. Okay, 76. So 76, now have to split 14 into 5 plus 14 into 5 is what? 14 into 5 is 70, then 6 needed. 70 plus 6, 70 plus 6, then 76. So which formula have to apply? That means 14n plus 6, 14n plus 6, which one? 14n plus 6, this one, arachno. This structure is arachno, means therefore this is an arachno metal cluster. Okay, this one is arachno metal cluster. Okay, similar type this one. Here n value is 6. Okay, n value 6, so 6 into, then cobalt, what is the balance electron? Cobalt is valence electron is 9, plus 16 into 2, now 9 6 54, plus 32, 4 plus 2 6, 8, 86. So 14 into 6 plus 6 4 the 24, then 6 1 the 6, 84, plus 2, that means 2. So 14n plus 2, this is closure structure. This one is closure structure. Okay, or closure metal cluster. Okay, this one is same process, you have to do by yourself. Okay, understood? So please subscribe my channels for upcoming videos. Okay, thank you.